This next one I don't actually count as one of my methods of factoring because I never do it. I kept it in here because the textbook had a section on it and I was like, so might as well cover it. And the other reason is that in chapter 3 we are going to be learning how to make perfect square trinomials. So if you've practiced factoring them here, it will make that easier. So I kept this section in here, how to recognize a perfect square trinomial, because this is probably the most difficult part of this factoring. So what's going to happen is that you're going to have a trinomial and you're going to have to know, oh, I don't use AC method for this. I can factor it as a perfect square trinomial because it's a perfect square trinomial. But you have to know that. So to recognize something as a perfect square trinomial, it has to match the following three features. One, it has to be a trinomial, meaning there has to be three terms. Two, the A term and the C term have to be positive perfect squares. And three is the trickiest one. Half the middle term, so half the x coefficient squared, has to equal AC. Whew, weird. So let's practice making sure that these are perfect square trinomials. So first thing first, they're all three terms. Awesome. Second thing, the A and the C have to be perfect squares. So 1x squared, 25. Good. 4x squared, 9. Good. 9y squared, z squared. Good. Now we're checking 3. 3 is that if I take half the middle term, so for this one, if I take half of 10 and I square it, do I get 25? I do. Yay! That's a perfect square trinomial. Okay, let's try this one. Again, half the middle term squared would give me negative 8 squared, which is 64. So then what I'm checking is that 4 times 9, so AC is 36. Since these are not the same, this is not a perfect square trinomial, and in which case I would check to see, can I find two numbers that multiply to give me 36 and add to give me negative 16? If not, then it's prime and it's not factorable. This third one, again, so I can just check AC first. So AC is 9. I'm going to take half my middle term and I'm going to square it and I'm going to see if it's 9. Yay, it is. So that's the first step. First step is recognizing something's a perfect square trinomial. And if you don't stress. Just factor it as a trinomial and you'll get the same answer. If you do recognize it's a perfect square trinomial, the factoring is so fast. Step number 1, greatest common factor. Step number 2, draw a bracket with the same sign as the middle term. Then you are going to take the square root of the ax squared term, so the first term, and you're going to write it first. Then you're going to take the square root of c and write it second, and you're done. And again, if you wanted to check this, you would say, okay, 2x minus 1 times 2x minus 1, I would get 4x squared minus 2x, which is minus 4x, plus 1, and I would know that it was good. So let's first of all check, are these perfect square trinomials? So AC is 49, half of 14 is 7, squared is 49. Awesome. Then I can do it. So I literally just draw one bracket with a squared. I take the sign of the middle term and then I square root. Square root of 49 is 7. Square root of z squared is z. Square root of 1 is 1. Done. Try the next one. Ooh, does this one have a greatest common factor first? Nope. Okay, so for this one, we are going to first of all recognize that it's a perfect square trinomial. Now this one's going to require a calculator. So 9 times 64 is 576. And then half of 48 squared is 576. Yay! Now you can see how this one would be kind of awful as an AC method because you'd be looking for two numbers that multiply to give you 576 and add to give you 48. And the trick is that when you do it, you'll notice it's 24 and 24. That's your second clue that this is a perfect square trinomial. But the way we did it, we're just going to draw one bracket squared. We're going to put the sign of the middle term, and then we're going to square root. So square root of 9a squared is 3a. Square root of 64 is 8. Square root of b squared is b. And we're done. Good job.